All right, you know what? I gotta stop that again. All right, so we have a rectangular well, 6 feet long, 4 feet wide, 8 feet deep. So we're gonna draw, oh, that's not very good, but we draw a rectangle and then at the top draw a little parallelogram look of it. And then we try to replicate that parallelogram down at the bottom to draw a three-dimensional deal here. So there's my rectangular well. It says it's 6 feet long by 4 feet wide by 8 feet deep. If water's running into the well at a rate of 3 cubic feet per second. So since that says 3 cubic feet per second, what is that? Rate of a what? Cubic feet. Whenever you label something cubic, what are you calling it? Anybody know? Y'all should know. Volume. So since that's cubic feet, that means that dV dt is equal to 3 cubic feet per second. Man, that's a lot. How fast is water rising? So we usually do a height. We usually let this be length, width, and height. So there's water in here. There's water in here that's rising. So we're looking for dH dt is what we want to know. And water, all right. Keep in mind which variables are constant. Okay, so as water's going up and down, what variables do not change in this rectangular prism? Length and width of the bottom. The bottom doesn't change, but the height, as water's coming in, the height's going up, right? So that means when we do the volume, you're supposed to know volume is length times width times height, or base times height times, or that's the way I think we did it back in the good old days. So I can plug in anything that doesn't change. So the volume and the height will be changing while the bottom part won't as water's going in. So when you get to this point, we can now do a derivative with respect to t. And then we're going to stick in there what we know. This is 3 cubic feet per second, which is super fast. And I probably should have put in here, this is feet and this is feet, right? Both those things are feet. So this is 24 feet squared. So that equals 24 feet squared dH dt. So I'm going to divide this by 24 feet squared, and I'm going to divide this by 24 feet squared. So this square will reduce with 2 of these. So this will be 3, oops, it'll reduce to 1/8. 24 and 3 reduce. 1/8 foot per second is how fast the height is changing in this prism. Okay? Anybody else got anything you want to say? Okay. So carry on. I'm going to see if this, I hope that speaker's working, but I got a bad feeling it's not.